Okay. When should I start?
1 second, please.
Okay, 1 second.
Okay, we're ready.
Should you go? All right. Okay, so hi everyone. Sorry I interrupted your break, but you will have another one after. In this talk we're going to talk about Bazel for us, Angular developers. And the good news is, all right, let me bring my mouse here. Okay. So the good news, if you're all using the Angular CLI, everything is configured and set up for you. So eventually you don't need to know anything about Bazel. So we configure everything, we set up all the configurations files, and you just have to use Angular CLI as before, like ng build, ng test, and you don't care about the internal. So thank you. That was my talk. It's easy, right? Okay, so actually I should have given another title for this talk, which is Bazel for the rest of us, because you can use Bazel even if you're not an Angular developer. For instance, if you're building Java or .NET or Android or other platforms. So you can use Bazel for that as well. So my name is Wassim Chegham. Yeah, that's me. I work at Microsoft as a cloud developer advocate for Azure, which is our cloud offer. And yeah, you can find me on the internet, like everywhere, GitHub, Twitter, just Google my name. And you can also find me throughout the whole day today inside the expert room. I think they call it like that. So yeah, if you have any questions about anything related to any of these topics. And I'm also a member of the Angular tooling team. So yeah, that's possible, Microsoft and Google. I created a bunch of open source projects, and I also contributed to others. So again, if you have any questions about open source, I'd be happy to answer. Also nominated by Google as a GDE, like Max, and a couple of us are here. For the 3 categories, Angular, obviously, Google Assistant, which is the chatbot framework made by Google, and yeah, the GCP, which is Google's cloud platform. Okay, so before I start, I wanted to really genuinely thank these people who welcomed me on the Angular team and who mentored me to learn Bazel and start contributing to the project. And I also want to especially thank Alex Eagle, who is the Bazel expert, I think, on the Angular team. So if you have any technical, complex question about Bazel, he's the one you should ask on Twitter. All right, so are you ready for a fun journey into Bazel internals, right? Yeah, okay. I know. It's lunch. Right. Okay, so before we talk about Bazel, let's understand what's the problem we're trying to solve, right? Because if there is no problem, there is no need for a solution. And I personally think that the front-end build process or processes is broken. Just think about it. I mean, there are lots of tools out there. Like in the previous past, there are like Grunt, Gulp, there's Webpack, there's a lot of build processes you can use and combine together to make them work and have your application ready. And you need to care about HTML, JavaScript, CSS, and even assets, or all those files that you need to optimize and output. So yeah, so there is something needed for this, the whole build process for front end. And usually, actually, the build time is somehow proportional to the numbers of files you have in a project. So the more files you have in your application, the more time it takes. And I think all of you agree with me. Also, maybe sometimes some of you have already asked this question, so why my 2 lines changes takes ages to rebuild? locally or on the CI. So yeah, that's another problem we need to solve. And also, yeah, the notorious phrase, it builds on a machine, it works on a machine, but I don't care about the CI. I don't know why these tests are failing or the build is not done correctly. So how can you fix this? What's part of the solution? So what we need to fix first is we should have build times that are proportional to the number of changes, not files. So if you're changing 2 lines in one file, you only need to build that one file, not the whole application. And also, ideally, you want to take only a couple of seconds to rebuild, even if you have thousands of components on or source files. And of course, you want to build everywhere. On your machine, on the CI, on the fridge, on the oven, anywhere there's JavaScript, you need to build. Just kidding. Okay, so one of the answers is Bazel, obviously. And so what is Bazel? So Bazel is a modern build and test orchestration system. So you would use Bazel to orchestrate all the workflow of your existing tests and toolings. So it's not meant to replace or your Webpack, your Angular CLI, or Gulp, whatever you're using. You're going to use Bazel to instrument and orchestrate all this workflow. So some of the benefits of Bazel are having incremental builds, meaning that if you change 2 lines of a file, you just need this file to be rebuilt, not the whole application. That's why we call incremental builds. Hermeticity, that means that all your, for instance, you have a package or you have a dependency, you need it to be built independently of the rest of your application. No shared scope, no shared dependencies. Everything needs to be local and hermetic. And of course, yeah, I forgot to mention, but Bazel is built by Google. So it's based on an internal tool they use at Google. They've been using for more than 12 years. Alex is somewhere here, so you can ask him. He works at Google. So yeah, that's really a guarantee that it's working fine. And also composable, because you can use Bazel little concepts we will talk about later and use them to compose your complex workflow. Deterministic, meaning that every time you call a build, you run a build with the same files, you need to have the same output, not a different one. That's what we call determinism. Yeah, as I mentioned before, you can use Bazel not only with Angular, but with lots of toolings and frameworks for Android, for C++. And if you are a OCaml or functional programming nerd, you can use it also for that. For today, we'll be focusing on TypeScript, because that's the plugins and the rules we built on the Angular team and we support for Bazel and for the Angular integration with Bazel. So these are some of the people who are using Bazel internally in their build system. Of course, there's Google, Spotify, many of them. And of course, Angular. So Angular is now built using Bazel. But not only Angular, also the Angular ecosystem, like the CLI, Material Design, and NGRX, I guess, and a bunch of them. All right. So we also have a sample application with Angular and Bazel. You can fork it on GitHub and try it out, and we'll be using it to demonstrate this talk. Yeah, and if you have any issue with while you were testing this app, please open issues there so we can talk about them and see what we can fix. All right. So let's start talking about Bazel concepts. So these are basically the concepts that even I wish I had knew a year ago when I started working in Bazel. So I'll share them with you. Bazel is actually a really complex project and lots of concepts, so I just focus on some of them during the time frame we have today. I hope they will be beneficial to you. So the first concept is workspaces. So Bazel work, the context of Bazel is workspaces. So workspaces are simply like folders where you have all your projects, and you have to have a file called workspace in capital. So anytime you have a file, a folder with a workspace file, this is considered to be a workspace, a Bazel workspace. Think of it about like a NPM project or Node.js project where you have a package.json. And yeah, folder structure, there is a workspace, so this is a Bazel project. And yeah, Bazel workspace can look really verbose. I'm just giving you some examples here. So it has a name, mandatory, and then you can use some internal functions, which is like using Python syntax, inspired by Python, which is called Starlock. So yeah, call functions to, for instance, download all the dependencies, like let's say Node.js, for instance, or here we need Kubernetes because we need to deploy this app to the cloud. So we need to call the Kubernetes binary and all the dependencies for that. So use it as if it was your NPM package. And the next concept is packages. So you have a workspace, and inside the workspace you have one or more packages. And a package is a primary code, unit of code that helps you organize your application. And again, a package is a folder which has a build.bazel file. So whenever you have a package, it's only one build file per directory, per folder. If you have a folder without any package, without any build.bazel file, it's not considered as Bazel package. And you should add one if you want it to be a Bazel package. So here we have a lot of them, as you can see into the Angular example project. And this is considered to be a good practice. Use really fine-grained packages or folders. So the content of a package file might look like this. It depends on what you're trying to build. So here we're trying to build an ng module. So for this, we load the ng module function from the library that we've built, from the rule that we built. And then, yeah, you may give it a visibility because of hermeticity, remember? And then call that function with all the required parameters. We will get back to this after. So into the Angular world with Bazel, we consider to be good practice to have one build package per Angular module. So it's one-to-one relationship. And even if you can go even like smaller and have really fine-grained packages, because this is really important for Bazel. Bazel will use these packages and build them in parallel. So if you have the whole application in one package, there is no need to use Bazel for that. So, and inside a package, a build file, so the ng module we showed earlier, for instance, these are called directives. So you have like sets of directives inside a build package. So these directives can be either like files. So these files are the code source that Bazel is gonna use to build your app. So these files can be written by us developers for our project, or they can be generated from other rules or plugins, and then feed back to the next rule. Targets can also be rules. So the ng module which we saw earlier, it's called a rule, which is basically a plugin if you want to. And also we have this other type, which is a group package, which basically like a way to group files together and use them as a whole, as a single unit. We will not talk too much about group packages. Next concept is label. So labels are a unique identifier of a target, and it should be globally unique. It's really important. So here's an example of a name of a label. So here we have a workspace name. It's at something, Angular Bazel example, which is used in reverse DNS names. Then we have a root workspace with /. Then we have the name of the package, which is the built-in feature here we're building, and the name of the actual target. So this is the canonical name of a label, absolute name of label. But you can also have like different shortcuts. You can ask me a question about this after the talk. So another important aspect of Bazel is rules. So I've been talking about rules earlier. Is that rules describe the relationship between a set of inputs and outputs, and also describe all the steps that you need, like to take. How can I take the inputs and build the output? So rules can be of three types. The first one are binaries, so anything dash binary, for instance, JS binary or Node.js binary. That means that we are calling the actual binary, Node.js or TypeScript compiler, and then giving it configurations, of course. They can be tests, so these will run whenever you run Bazel as a test orchestrator, so it will only run these rules for you. And of course, like libraries, so you can call the test library, for instance, to give it a TypeScript file, and it will give you a JavaScript file. This is an example of a test library inside the shortened package. So you call the test library function, you give it a name, and then a set of inputs. So here we only have one file, which is shortened.ts. You can give it extra optional or mandatory properties, which are required by the specific rule. And then, of course, you have to list all the dependencies for this specific rule. Hermetic, remember. Nothing goes in, nothing goes out. This rule needs to have everything. It needs to be built and rebuilt safely. And there is an implicit output, which this rule gives me a shortened definition file with a JavaScript transpiled file. So to give you a visual representation of this, you have this test library rule. You give it inputs, which are TypeScript files, and it will give you a JavaScript transpiled files. And what is cool about this is you can compose rules. So for instance, I can take the output of the first rule and feed it into another rule. For instance, the rollup bundle here. So it will take all my JavaScript file and give me one single UMD bundle. The last concept of Bazel are actions. So you will hear a lot about actions inside Bazel. So actually, actions are where you really describe the implementation of, I have input files, how do I generate output files? So this looks familiar. This is what you use in mathematics, function. You give it an input, you will have an output. And because it's deterministic, you will always have the same output given the same input. And of course, we can consider it be like pure function, so there is no global state or shared dependencies. So you can see it as functions. Again, the same TS library rule. There is the input, there is the output, and internally there is complex implementation. So I just sum it up as calling the test binary and give it a particular configuration file, and you will get your output. And basically all the rules follow the same pattern. They basically use internal programs. So for instance, you can have a Webpack rule that's the same pattern. Input, call Webpack loaders, and then gives you an output. We also have rules for Node Sass, compiling like Sass or less CSS files, and a bunch of them. So these were the basic concepts, building blocks of Bazel, and like anyone who wants to start using Bazel should know, me including myself. And there's another interesting concept you need to know about is it's the evaluation model, how Bazel uses all these actions and give you the actual result. So there are three phases when you run a build or a test using Bazel. The first pass is the loading phase, where basically Bazel will load and evaluate all the extensions, all the build files, and make sure that everything is ready for the next phase, which is the analysis phase. During the loading phase, Bazel will build a graph that will pass to the next step. And in the next step, Bazel will make sure to verify all the dependencies that are like present, available, and there is no missing dependency or broken dependency. Otherwise, it will fail in this step. And when everything is ready, this generated graph from the analysis phase would be passed to the execution third phase, where the actions are run, executed. And this is also where all the tests are run, by the way. All right, so again, visual, I like visuals, so that's the way I prefer to learn like this. So you have your execution model like this, all the actions and their explicit and implicit dependencies modeled like this. So Bazel uses this concept of graph, internal graphs, to make it seem clever, because it will Bazel will easily detect which inputs, which actions have changed, and which actions needs to be really executed. So here we only change 2 files in 2 different folders, maybe, or so it matches to these 2 actions. So Bazel knows that it needs to rebuild only these 2 paths. And because Bazel knows that the blue actions and the yellow actions don't have any common dependency, so it will be able to run both in parallel and speed up the build process. Bazel also uses caches. I mean, whenever you call an action, it gives you an output. This output would be cached, and Bazel will apply a hash function to identify the cache. So again, same pattern. If it detects that some cache was invalidated, so all its dependencies will be marked and rebuilt. Only these parts of the whole cache. So imagine we have a developer who's using Bazel. So he would call any rule, and this rule needs our source code, so we give it a source code. And then Bazel will create a cache, or just rebuild the required or invalidated files. And then it will use, if you're running on your local machine, it will use all the available CPUs to run the different caches, actions, excuse me. For instance, on this Pixelbook, I have 4 CPUs, so it will use all the 4 CPUs to build the required actions. But it's also really great for another thing. Bazel can use a cloud instance or a remote instance to run your cache or your execution remotely. For instance, for the cache part, instead of building the cache locally, it will build it locally and then upload it to a server. This is really great because if you're, when you are working on a team, other teammates will benefit from your build. When you came back in the morning, build your app, so the cache will be saved in shared cache, and other teammates would use it and don't have to rebuild everything from scratch. The same thing goes for the execution phase. Bazel, if you're running Bazel on the cloud, for instance, or even on a server or a machine in your basement or on your home, you would use all the available CPUs. Or for instance, if you're using a cloud, you have many CPUs to use, so it's really good. And you can use any cloud provider, GCP or Azure, for instance. There is also a neat feature where Bazel can run dynamic execution, like locally and remotely, and it will detect which build is the faster and then get the result from the faster one. For instance, for like small changes, it's not really great if you run them on the cloud, because you have the wire, you have internet, latency, all that stuff. It's faster to build it on your machine. So on the Angular team, we, of course, we're using Bazel to build Angular, so we switch from an hour of build to 7 or 8 minutes build for the Angular framework. So there are results. You should really take a look at Bazel if you have similar products, like a huge product. There is a really cool command line in Bazel where you can generate, I'll zoom it, sorry. When you can generate these actions graph and you can see it for your project, which dependencies are involved and which files are involved as well. And yeah, this was taken from my previous company on a real enterprise project. And by the way, this is not a good architecture. So you need to rethink this kind of projects, like spaghetti code. Okay, so if you're using the CLI and you've told me all of you are using it, so I'd like you to go today and download Bazel for your project. So if you can start a new fresh application using the Angular Bazel schematic, or you can add Bazel to your existing project. Please keep in mind that this is experimental, so you will face issues maybe, especially with external libraries, JavaScript libraries, not with Angular itself. And if you find any issue, please open an issue on the repo. If you are adventurous, you can also use Bazel outside of Angular. So you can install it. There is a pre-built binary, which is at bazel/bazel. And yeah, you can run directly Bazel on this command line. For instance, for building, here we are building the SRC package and targeting the bundle target group. Or you can run a binary. Here we are running npm, for instance, or just ... means every dependency in a project. This will take a long time, so don't do it on your machine unless you have a robust machine. Or otherwise, yeah, you can, of course, install Bazel from source if you're really into that. Okay, there are two resources you need to remember. The first one is the landing page of Bazel on the Angular IO. So this is Bazel for Angular. And the second resource is the official website, bazel.build, where you have all this concept that I showed you, plus more others and lots of cool stuff to see. All right, so that's all for me. Thank you so much.